Hello everyone, today our group is going to talk about the blockchain for medical IoT security. The presentation are presented by members Luoying, Bokai, and Lihua. In the traditional part, I will focus on introducing what is blockchain and security issues in the medical Internet of Things. At most basic level, blockchain is literally just a chain of blocks, but not in the traditional sense of those words. Blocks on the blockchain are made up of digital pieces of information. Specifically, they have three parts. The first part is block store information about transaction like the data, timestamp, and dollar you have paid. The second part is block store information about who is participating in transactions. The last part is block store information distinguishes them from other blocks. The blockchain was firstly invented in 2008 to serve as the public transaction ledger of the cryptocurrency Bitcoin. Security issues in the medical Internet of Things mainly exist in privacy authentication and data security. There are four risks in the privacy protection. The first one is attack by computer virus. Medical privacy explode without being noticed. The second one is the tracking of the medical equipment by the radio frequency identification system. Use threaten privacy and security. The third one is the medical equipment is monitored by the manufacturer. The last one is the security of traditional channels is difficult to provide an effective countermeasure for security attacks in many situations. The authentication is the key safety measures. IoT authentication includes identity authentication and message authentication. The key can reasonably ensure the users complete the identity authentication. However, if the key is stolen, the data security of the stolen user is threatened. Even the attacker will steal the data in the whole communication system. Message authentication can ensure the security and integrity of the information when the sender and receiver exchange information. But authentication code is generally static data, and the attacker can easily pretend it to be the receiver by monitoring the data stream, thereby stealing the relevant data of the sender. In terms of the data security, the data in the IoT can be regarded as the dynamic data collection continues to grow over time. However, the transmission of a lot of data will increase the load of serve, and the security of data will be reduced.
In this section, our group introduced an improved model based on blockchain technology. First, I will talk about some basic blockchain characteristics and their drawbacks, then show how the improved model can address the problems. The first one is decentralization. In basic blockchain, there is no central node. Every node has equal status and has a complete record of the whole database information. However, this may result in very low scalability as users increase. In our model, this problem can be addressed by multi-cluster overlay network. Second is trustless. In the blockchain network, data transmission at all nodes is open. However, for medical data, privacy is the leading concern. In our model, we use ring signature to make sure that no one knows from whom the signature comes except the signer himself. Third is data storage. In practical medical IoT network, it's not feasible to store such a huge database on the blockchain. Therefore, we use cloud to store big data and use hash function to make access control. Last is data security. Blockchain uses asymmetric cryptography to ensure data safety. In our model, to better improve data security, we use double encryption mechanism. That is, we first process data with ARX algorithm, then encrypt the data with private key, and finally encrypt the private key by using the public key of receiver. Then I will introduce how the model works. The first part is overlay network, which is based on P2P distributed structure. The network uses multi-cluster to improve scalability, then uses digital signature and public key to ensure secure data transmission. For example, if a patient wants to share his data with the doctor, the cluster will broadcast the transaction in this group only if the patient's signature is valid and the doctor's public key address is available. The second part is cloud data storage. In our model, data is stored in multiple blocks on the cloud server, and the server uses hash chain to control correct data updates. That is, when data changed on cloud, the cloud server will calculate the new hash, send it to the overlay network together with the root hash, and the overlay network will accept the new hash only if the root hash matches. Then we will talk about the algorithm used in this model.
Thanks, Luoying. Hi everyone, this is Lihua. After talking about the improvement model, let's focus on the techniques using in the blockchain. In our model, we apply ARX encryption algorithm to encrypt data and use one example of the latest usage of ARX cipher spec, which has a file-like structure and each block is divided into two branches, where both of them are modified by XOR operation at every round. We use the Diffie-Hellman exchange technique to share the public key secretly with the network. We also use ring signature technology, which allows signers to sign data anonymously. A user sends a request to make the transaction to the blockchain network with a public key. After receiving the request, the network sends back a certain number of the public keys, which are collected from other members who also applied for the ring signature. Then, the signers can generate the signature independently by using his or her private key and the public keys from other members. There are some pseudocode to implement the algorithms of cryptographic techniques between senders and receivers. For data encryption, we use the symmetric key to produce the ciphertext, then double encrypt the symmetric key with the receiver's public key, and send the key together with the ciphertext. As for decryption, we need to first use the receiver's private key to decrypt the key and obtain the original symmetric key. Then we apply the key to the ciphertext and obtain the original plaintext. To add the digital signature, the sender first passes the data file to the hash function and creates the hash value of the data, then sends the data using his or her private key by passing the value of the private key and hash value to the signature algorithm. The signer's public key can be used to verify data on the receiver's side. We also add ring signature for applying anonymity of the user. The process has been described in the block diagram of our model.
This part, our group will focus on the evaluation. First, this model satisfies the basic CI requirements. The data is encrypted through double encryption, thus ensures the confidentiality. The data integrity is guaranteed by hash chain, and the availability is ensured by multi-cluster overlay network. In addition, the model can also guarantee authentication and anonymity through ring signature.
There are several pros and limitations of the technique in model. For ARX encryption, SPEC is one of the fastest cipher available running well on various IoT devices. It also can safely resist CPA and CCA attacks as well as related key attacks. However, due to small block and key sizes, it's hard to prevent from bursty and brute force attacks. For Diffie-Hellman key exchange, because of random output by hash function and DLP, external observer would not easily calculate the shared secret value, so we can consider this way as information theoretic safe. However, Diffie-Hellman algorithm is computationally intensive. It is vulnerable to blocking attacks. By using ring signature, we can achieve signer's anonymity and signature correctness, which make it more prominent in terms of privacy and data security. However, there are some limitations in size of rings and public keys. Besides, due to the unconditional anonymity of the ring signature itself, the signers can frame untrue members in the group.
In conclusion, our group proposed an improved blockchain model for secure medical IoT system and evaluated based on CI and technical requirements. This is a reference of our presentation. Thank you all for the listening.